Okay, let's get started. Okay, so again, you have a quiz due in 7 hours. Make sure you do it. Okay, so let's start. So today we'll be sort of going over like the first half of the Cauchy sequence section. So, okay. Sn, so we say Sn is increasing if Sn is less than or equal to, so the next term is always bigger than the previous one. So, and note, increasing is not strict, right? So it could be equal, right? So like the constant sequence counts as increasing because it's always equal. And decreasing if vice versa. The next term is always smaller than the previous one. And we say Sn is monotone if increasing or decreasing, right? So examples would be, Sn is 1 over n. This thing is decreasing. And increasing, you could do something similar, like 1 minus 1 over n. This one's increasing. It's increasing the 1. And why do we like this? It's because all bounded monotone sequences converge. So this theorem, you really don't need to know the proof because the idea is simple. So let's say I'm bounded, right? So let's say I'm bounded like here, right? Bounded means top and bottom, right? So if I'm bounded and I'm monotone, let's say I'm increasing, right? Let's say S1 was here. If I have two choices, right? Either I stay the same or I sort of keep going up. And the point is, if I don't stop, then I keep going up. If I stop, then I converge, right? If not, then I keep going up. But I can only go up so much, right? I can't really, go past the bound, right? So what you're gonna see is, okay, what would it converge to? Well, let's take the least upper bound. If it's increasing, let's say this one was the least upper bound, like this, the supremum. Then again, by the property of sup, I have to have a sequence going to it, right? Because if it stopped beforehand, so if it stopped like right here, for example, if it stopped here and there's nothing here, like nothing here, then this would be my new least upper bound, right? So there has to be a sequence that goes to the sup, right? And I know that it must converge. So in particular, so I'm saying for increasing, we know what it converges to. It converges to sup of S. And for decreasing, it converges to infimum of Sn. So we like bounded monotone sequences, right? Because they converge. So can anyone give me a sequence that's bounded, not monotone, that doesn't converge? Anyone? So the classic one is this, right? We don't want stuff like this, right? Stuff like sine that's oscillating, -1 to the n that's oscillating, right? Like we don't like that because I mean, this thing is certainly bounded, right? I mean, the values are only -1 and 1, but it doesn't converge, right? So the nice thing about monotone sequences is that converges. And it's even nicer, right? So here, 10.4, this theorem 10.4, if Sn is unbounded, it's clear what the limit is, right? If you're not bounded and you're increasing, for example, is unbounded increasing. So either you keep increasing or you stop, right? But if you keep increasing, then what? Then limit n goes to infinity. Sn is positive infinity, right? And if Sn is unbounded decreasing sequence, so then, you know, limit n goes to infinity, Sn is negative infinity, right? So you have two cases, right? So if Sn is monotone, you have the first case where Sn is bounded, monotone sequence. Then either Sn converges, right? Or diverges to plus infinity or minus infinity, right? So it's true it might diverge, but it diverges in a way we know, right? We know it either goes off to plus infinity or minus infinity. There's no diverging this way, right? Here it diverges, but does not go off to plus infinity or minus infinity, right? So you see here, like increasing functions are very nice. Increasing / decreasing, right? So now this gives a notion, right? Because here, limit, this thing does not exist, right? But we need a way to characterize does not exist. So what do we consider instead? So we say, okay, maybe, you know, limit is not the right thing to consider. Let's consider like an upper bound for limit and lower bound. And what that turns out to be is the limsup and liminf. So let's define. So for the rest of this, for the rest of today at least, I will sort of go over examples of limsup because I know when students see this, it's very confusing. So this is limit n greater than goes to infinity, supremum n bigger than n of, you know, so like of the sequence, of the sequence Sn. Yeah. And it's sort of exactly, if you read it, right? Limsup is limit of sup. And liminf is limit capital N goes to infinity, and then similarly infimum. Now, if it were me, I would have put the equal sign, like n greater than or equal to n, capital N, but I guess the book just doesn't care about the first term. So let me just write out what this means. So when I write limit, right, it should be limit of a sequence, right? So this is limit of, you know, n goes to, what's n equals 1? So it's n greater than 1 Sn, sup n greater than 2 Sn, ... right? So this is when n equals 1, n equals 2, and so on and so forth, right? So you should think of limsup as limit of a sequence, but every term in the sequence is a supremum, right? So, and similarly here, you will get that this one is infimum of n, lowercase n, bigger than 1 Sn, infimum n bigger than 2 Sn, and so on and so forth. So why do we like this? Well, what am I doing here? Let's sort of explore this, right? If I had Sn is S1, like why do we like this, right? S2, S3, S4, right? What is sup n bigger than 1 of Sn? So I'm taking the supremum over all the terms where n's bigger than 1, right? So here, this is just, I'm taking supremum over S2, S3, S4, and so on and so forth, right? Sup n bigger than 2Sn is the supremum. And now I only care about n bigger than 2. So this is S3, S4, S5, so on and so forth, right? So, dot, dot, dot. Now, question, which one's bigger? Is sup, is this, which one of these two are bigger? So let me say 1, 2. Is 1 bigger than equal to 2 or 2 bigger than or equal to 1? What do you all think? Did I put my voice on? Oh, okay. Oh. So here, what is 1? I'm taking sup over, so here I'm taking, this is a subset, right? Do you agree? Like the set, like this is a subset of the top. The bottom is a subset of the top. And if I'm so on the top, I'm taking a sup over more elements, right? If I take the sup over more elements, I'm bigger, right? Like for example, like the bottom could be, if it's finite, let's say 1, 2, 3. And if it's a subset, then let's say this is 1, 2, 3, 4. It could be like the sup here is certainly gonna be bigger than or equal to the sup here, right? Because here I'm taking sup over more things, right? So I mean, or it could be equal, right? Because here instead of 4, it could be 1, right? But here, what you're gonna see is the top one has more elements in it, right? And like it's a subset. So I'm taking a sup over more things on the top. So we actually have 1 is bigger than or equal to 2, right? So this one is bigger than this one. And similarly, the next one's bigger than this one, right? So like, for example, sup n bigger than 2Sn is bigger than or equal to sup n bigger than 3Sn is bigger than or equal to sup n bigger than 4Sn, so on and so forth, right? So what is the sequence? This sequence is decreasing, right? So, and what did we just go over about decreasing sequences? Why do we like monotone sequences? It's because either it converges or it's plus infinity minus infinity, right? We have none of this stuff. So limsup, and similarly, what about this one? For infimum, if I take an infimum over a bigger set compared to infimum over a smaller set, the infimum of a smaller set the number is bigger, right? Like for example, let me just write an example. So infimum of like 1, 2, 3, 4 compared to infimum of like 2, 3, 4. Like, and this is a subset of this. It's certain the thing increases, right? Because it could be you got rid of your lower bound when you move on, right? So here, this thing is increasing. Right? So liminf and limsup, it could not exist. It could, but if it doesn't exist, it's plus infinity or minus infinity, right? So we have none of this other kind of does not exist because these are increasing and decreasing sequences. Okay, is everyone clear so far on how limsup? I'll do examples, but hopefully we are all clear on how this works. Okay, so example. So -1 to the n. Let's do that first, right? So limsup of, I'll write the Sn version and then, let's take it step by step. Sup n bigger than n of Sn. which in this case, Sn is, 1 to -1 to the n. So here it's this, right? So this is just the sequence limit n goes to infinity, sup of this sequence, right? N bigger than 1, -1 to the n. Sup n bigger than 2, -1 to the n. Sup n bigger than 3, -1 to the n, so on and so forth, right? So here, what do we get? So what is this term? Let's try to calculate this term. So I'm taking, so what is -1 to the n? -1 to the n is -1, 1, -1, 1, -1, 1, so on and so forth, right? So if I'm taking, this is for n equals 1, right? And I'm taking n bigger than 1, so my sequence is 1, -1, 1. I take out the first term, right? So it's sup of this. Okay, what is the supremum? It's hopefully it's obvious what the supremum is. What's the biggest value this can be?
1.
Yeah. Okay, now what about this one? Here, I'm taking out the first and second term, right? So I take, and which is just taking out this term here. So again, what is the sup? It's still 1, right? And what you're going to see is that this thing is just always 1, right? So this thing is just limit n goes to infinity of the sequence of 1s, right? We normally just write 1, but just to be clear, and this clearly converges to 1, right? So now let's go for liminf. So this is limit n goes to infinity, sup, oh, sorry, why did I write sup? Inf. Inf n bigger than n, Sn. So let's write out what Sn is. Okay. Now let me just write out what the sequence is, right? So again, you should think of like this as like a, limit of a sequence of infimums. Okay, so let's figure out what the first term is, right? What is this infimum? So again, what is the sequence, right? The sequence is -1, 1, -1, 1, -1, 1, right? So n bigger than 1, I'm taking out the first term. So it's infimum of 1, -1, 1, -1, 1, -1, right? And it's clear that the infimum of this set, the smallest value is like -1, right? And similarly, if you do this, here I'm taking out the next term, so -1, 1, -1, -1, -1, right? The infimum is still -1, right? So what you're going to get is I'm doing limit, going back to this, all the terms inside is just -1, right? And then, so this is the limit, right? So you get limsup is 1, liminf is -1. Any questions so far? Okay, so let's do something, let's start a bit more difficult. Limsup of 1 over n, yeah? So this is limit n goes to infinity, sup n bigger than n of 1 over n. So again, let me, just to take things step by step, this is just this, right? So on and so forth, right? So when n is 1, which is sup, n bigger than 1, 1 over n. For example, so similarly, like here, this was like capital N is 1, right? Capital N is 2. So, okay, so here, when capital N is 1, I have this term. And what's the sequence 1 over n? It's 1 when this is n equals 1, a half, a third, a fourth, so on and so forth, right? So this thing is what? It's supremum. I take out the 1. So it's a half, a third, a fourth. What is the sup of this set? So what's, hopefully you all know this. What's the biggest number you see?
1.
So it should be a half, right? So, but another way to write this is 1 over n plus 1, right? Because n is 1. So the reason I write this is because I did this before. So n bigger than sup n greater than 2 of this is what? It's sup. I take out a half now, right? So there's a third, a fourth, a fifth. And the sup now is 1/3, which is still 1 over n plus 1, right? Because in this case, n was 2. So 1 over 2 plus 1 is 3, right? 1 is 1/3. So, and similarly, you could show that, you know, you'll always get 1 over n plus 1, right? So here it's the limit n goes to infinity. I'll write it like this, but you know, but this is like when n is 1. So this is just another way to write 1 over n plus 1, right? This is when n is 2. This is again 1 over n plus. So this is just limit n goes to infinity 1 over n plus 1. And what is this limit? We all know this, right? It's 0. Okay. So in this case, we actually don't get a constant function, right? So the reason there was no n on top here was because the infimum was just constant. It didn't matter what n was. It was always -1. So here it's a little more difficult, but okay. Now liminf n goes to infinity of 1 over n is limit n goes to infinity of infimum n bigger than n of 1 over n. Now this thing is, again, let me write it out. This one, capital N is 1, capital N is 2, so on and so forth. Now let's figure out what this is. So again, I'm taking infimum n bigger than 1 of this. So again, if you look at, you know, this part, I'm just taking infimum of this sequence, right? 1/2, 1/3. And what's the infimum of this? So the infimum here is 0, right? I mean, hopefully it's clear as the thing is approaching 0. And similarly, what you're going to see is this one is also 0, right? Because even if I take out the half, it's still going to approach 0, right? So you're going to get 0, 0, 0, 0, 0. So this thing is just all zeros. So this thing is just, you know, 0, 0, 0. We normally just write it like this, right? A lot of people just, you know, write it like this. So that's just 0, right? So they're both 0, but for different reasons, right? The limsup was 0 because it was the limit of 1 over capital N plus 1. The infimum, the liminf was 0 because the sequence was just all zeros. So, okay, so let me sort of explain the main theorem now. So we always have that, you know, first off, we have that liminf is less than. If it exists, right? Actually, let me just write. Yeah, okay. This is pretty bad. So let me write this. So is less than or equal to limsup, right? So this is always the case. So you should think of like actually let me just write the theorem. So one, if limit n goes to infinity, Sn is defined. So by define, we don't mean converge, but you know, it either converges is plus infinity or minus infinity. Then we have this. N goes to infinity. Liminf of Sn is limit n goes to infinity. Sn is limsup n goes to infinity. Sn. So if the limit exists, the limsup and liminf are equal, and it's just the limit, right? So nothing too fancy about that. So, and also if liminf is equal to limsup, this one's the big one, then the limit exists, so f Sn. So if you calculate the liminf and limsup, which should be, you know, in some cases easier because it's increasing and decreasing, right? You're calculating limits of increasing and decreasing functions, then limit exists, and it's equal to whatever the liminf was, right? Which is also the limsup. So the way you should think about this is the limsup is like coming from above. If this was the limit, right? The limsup is coming from above. Liminf is coming from below, right? And if they both converge to the limit, then you know you have it, right? But it could be they stop somewhere, right? So just reality check, right? From part one, we know that limit n, where was it? This one. For our second example, I did limsup of 1 over n, right? But we clearly know, we know this, right? This is clear. So from theorem part 1, we get that, you know, these all should be equal, right? Because we get that it's defined. It's the s is like 0, the limit 0. So liminf and limsup should be 0, and that's exactly what we got, right? We got liminf was 0, limsup was 0. Agree? And similarly, if limit n goes to infinity, Sn negative 1 to the n existed, then from theorem 1, right? The liminf is limsup, right? From theorem 1, liminf of negative 1 to the n is limsup of negative 1 to the n. But that's clearly not the case, right? Because when we calculated above, the liminf was negative 1 and limsup was 1, right? So if liminf is not limsup, your limit can exist. So, right? So, yeah, but they were different. So one way to check a limit exists is check the liminf and limsup are equal. Okay, any questions so far? Okay, so let's go over something important. So, whoa, where am I? What chapter is this? No, next one. Okay, so yeah, this section is long. I think that's why your professor, you know, made it like two lectures. Okay. Is there something to practice limsup? No? Oh, section 11. Okay, well, let me just go section 11 then. So since we didn't really go over Cauchy sequences, I don't want to do problems on Cauchy sequences. So, okay, this is perfect actually. So, yeah, let's do this. So I did 11.2 AN, yeah, at least 11.2 part C for AN. So, and I also did it for BN. So what is CN? So let's do CN, but before that, I think there was an important example. Maybe not. Okay, so let's do one more for like CN, I guess. I saw a problem that was like yeah, this one. Let's do this one. So this one's important. So the SN is 0, 1, 2, 0, 1, 2, 0, 1, 2. This part's important. So SN is 0, 1, 2. So it's a sequence given by this, right? 1, 2, 0, 1, 2. And TN is given by 2, 1, 1, 0, 2, 1, 1, 0. Okay. 2, 1, 1, 0. I try to line up 2, 1, 1, 0, 2, 1, 1, 0, so on and so forth, right? And in fact, I think I'm gonna change it a bit. So I'm gonna make it just 2, 1, 0, 2, 1, 0. Yeah, I want to sort of demonstrate something. Okay, question: what is limsup of SN? So if it's this, right? This is limit n goes to infinity, sup n bigger than n, Sn, right? Now, again, this is just this, n bigger than 1, sup n bigger than 2, so on and so forth, right? Now, what is sup n bigger than 1, Sn? This is sup of this set, 1, 2, 0, 1, 2, 0, 1, 2, so on and so forth, right? So the biggest number is 2, agree? And similarly, you know, sup n bigger than 2 Sn. It doesn't really matter how many terms I take out because it repeats, right? So this is 2, 0, 1, 2, 0, 1, so on and so forth, right? So you see the supremum is always 2, right? So this is limit n goes to infinity of the sequence given by this, right? So for shorthand, people normally just write this, right? But you when I write this, you shouldn't think of it as a number, right? Because we think of it as sequences. So when people write like limit n goes to infinity of 1, it's like the sequence of ones. Yeah. So that's the limsup. Now, what is limsup of Tn? So hopefully it's the same thing, right? So this is limit n goes to infinity, sup n bigger than n, Tn, which is just this, right? Sup n bigger than 1 Tn, sup n bigger than 2 Tn. And hopefully you can all see that this is just 2 as well, right? Because what was Tn? Tn is 2, 1, 0. So if I take out the first term, it's 1, 0, 2, 1, 0, 2, so on and so forth, right? The supremum here is 2, and the sup here is still 2, right? So 0, 2, 1, 0, 2, 1. So here are both limsups are 2. This is again the sequence of 2's. Okay, now what about limsup? So this is what I wanted to tell you. What is this? So don't make this mistake. I want this one. So this is limit n goes to infinity, sup n bigger than n. So I want the product now of Sn Tn. So again, this is limit n goes to infinity, sup n bigger than 1 Sn Tn, sup n bigger than 2 Sn Tn, so on and so forth. But let's figure out what Sn Tn is. So if I multiply the two, what do we get? I get 0, 1, 0, 0, 1, 0. So it sort of looks like 0, 1, 0, 0, 1, 0, 0, 1, 0, right? So SNTN, let's write out the sequence. It's given by 0, 1, 0, 0, 1, 0, 0, 1, 0, so on and so forth, right? So sup n bigger than 1, SNTN, is what? It's 1 is sup, sorry, let me write it bigger. It's sup of this set, right? If I take out the first term, 1, 0, 0, 1, 0, 0, so on and so forth, right? The sup is 1. And similarly, you can check that you'll always get 1, right? Because there's infinitely many 1s. So the limsup of n goes to infinity of SNTN is just limsup, sorry, this should be capital N. It's just limsups of 1s, right? And this is just, sorry, limit. I'm just copying down this part. So it's limit, and so shorthand is this, and this is just 1, right? So what you're gonna see is this is not true, right? So I'm saying don't make this mistake. Times limsup Tn is not limsup of SNTN. So I guess it's something similar to the fact that similar to idea that sup of like some how do I want to say it, the sup of like Sn plus Tn is not equal to sup Sn plus sup Tn. The problem here is this one should be bigger. The right hand side should be bigger because if you think of, how do I say this? So the idea is like this one, I'm only consider the, the supremums of like these terms, right? Sort of the idea. I guess I wanted to say max, but anyhow. So I guess I got, yeah. Anyway, so like this one, but here I'm taking sup over all S1s, and this is sup over all. So like this one is certainly bigger than Si plus Tj for all Ij, right? So these two terms combined is bigger than all of these, right? So it's certainly bigger like S1 plus T2, S2 plus T1, right? But the problem is this one, the sup is only bigger than all of these, right? The indexes sort of have to be the same. So like you sort of see that like here is certainly bigger than this one, because here the indexes have to be the same. Right? You're only taking sup of like S1, T1, S2, T2, like we don't care, don't care about like S1, T2, right? For example, right? While on the left-hand side, it's certainly, it's all possible combinations of them. So, okay, any questions so far? So again, don't assume regular limit laws apply to your function. But yeah, okay. That is all I have for today. So I'll leave the last 10 minutes for maybe homework questions or let you do your quiz. So any questions so far?
Can you show the theorem again?
The theorem, right?
Yeah.
Where is it? Where is it? No, it should be down. And there we go.
Yeah.
Okay, yeah. This part it should be like homework question. So the theorem is like, you know, this is the theorem. But I just, you know, wanted to tell you like this. So like limsup is kind of approximating limit from above, and liminf is approximating limit from like below. And you could show that, right? Because limsup is certainly bigger than limit, right? Because limit, you just consider the sequence. Limsup, you're considering like the soup of the sequence, right? So limsup is certainly bigger than like limit, you know, ideally, right?
Yeah.
Bigger than or equal to. Okay, are you good? Or...
Can you do 8.8b?
Sorry, I'm gonna go all the way. 8.8, chapter 9. Yeah, so this thing you just need to show is less than epsilon, or minus a half is less than epsilon, right? So root n squared. Is it plus n? Can you tell me? I don't want to. Plus n minus n. Minus a half is, you know, we have to bound this, right? So let's put this over 2, I guess. I think. Yeah, sure, why not? So let's put this over. Do I want to normalize this? Yeah, let's normalize this first. So root n squared plus n minus n. If I multiply by plus n, I'm not changing anything, right? So this is n squared plus n minus n squared over. Yeah, everyone agree? So I can rewrite the first term as, and then these cancel. So n squared plus n minus a half. And let's, you know, combine denominators. So this is certainly, ooh, maybe I didn't want to do that, but okay. So n minus root n squared plus n plus n. So this should be 2n, right? Over 2 times. Ah, this looks nasty. Okay. So this is going to be root n squared plus n. Yeah, I should have combined first, but oh well. Should I? Yeah. This should be, let me think, does this simplify? So if I do n squared, I have n over, oh yeah, this, or this should be negative, right? Sorry, there should be a negative sign. So let me just write. If I made an algebra error, please tell me, because okay, this is fine then. So this is certainly gonna be, if I multiply by n plus, so let's multiply top and bottom by n plus now to get rid of the, multiply by n plus root n squared minus n. I want to get rid of the square root. So I would just get the square, right? So let me rewrite this clearly. So this is n squared minus n plus n, and then I'm multiplying by the same thing. So I get that this is n squared minus n squared minus plus n, right? On top. And I get this. So this is nice because what will happen is I get root n squared minus n plus n squared. And so basically you could bound this now. This is easy. So this becomes minus n plus n squared. And I can just get rid of this, right? I mean, I'm bounded by just n over 2n squared, right? Which is equal to 1/2 n. And this certainly goes to 0, right? So you could certainly choose n such that 1 over 2n is less than epsilon. So again, I just made this 0 because if a smaller denominator makes the number bigger, right? So do you have any questions? Or hopefully I didn't make algebra mistake, but I think it's just multiply by conjugate. It's just tons of multiplying by, yeah. If you see square root, chances are it's a multiply by conjugate.
Okay, thank you.
No problem. Huh? 6.1c. Oh yeah, I just showed that. Let me stop recording first. So